So, page 61. Now, actually, just give me a pen there. I marked the one that was wrong. So, what was it? 2B and 2D. Okay. Right. So we're going to look at equations with logs in them. So like I said for the first class, there's no new rules. We're just going to use our rules to solve equations with logs. But one big difference between this class and the last class is that we have to be careful we never have log the negative number. Okay? So for example, let me start off with 1D as a simple one to start. Log 9x equals 2. Now who can tell me what x is here? I mean, you just have to look at it and see the answer. No, not 3. 81. You went the wrong way. X is 81. Okay? But before you write down the answer, it's important that you write down your restriction on x. X here must be greater than 0, right? Yes? Now, in fact, all I need you to do for question 1 is just write down the range for x, what's possible for x. So like for example, if I look at 1a, I just need to say what is allowed for x. Now, I know you could work out what x is, but I'm not asking you to tell me what x is. I'm telling you what x values could it be. So for example, could x here be positive?
Yeah.
Yes. Could it be 0?
No.
It could be 0. And it could be negative.
We're still doing 1B.
Oh, sorry. Well, it doesn't matter. 1b. Okay, so here x could be positive, negative, or 0. And this is how you can remember. The base should be positive. The argument should be positive, but the result can be anything. Okay, so here we can say x is, if you want to write it like this, between minus infinity and infinity. So I'm not asking you to solve it here. I'm just asking you to write down what the x could be. And I'll say it again. If it's in the base, it must be, or should be, usually positive. The argument should be positive. But the answer could really be anything. Okay? Now, let's have a look at 2. Now to begin with, you might say, well, this doesn't have any logs in it, so why is this a log equation? Well, the reason is we have to use logs to solve it. Okay? Because in the last lesson, what would we normally do here with the number here? Yeah, you would write it as 5 with a power. Yes? So like for example, if this is 25, what would I do?
5 squared.
5 squared. But I can't do this here. No amount of thinking about it will change 4 into 5 with a power. So the way you deal with this, does anybody know? Yeah, you could do log 5 if you want. But what I'm going to do here is put a log on both sides, okay? And it can be any log that you want. So I'll use natural log, since I know that's on everybody's calculator. Although some people might have, some people's calculator will not allow them to set the base. But everybody's calculator in this room has natural log on it, so that's the one I'll use. So I'll put a natural log here and a natural log here. Now before you go ahead, I should use a rule of logs here. What rule should I use? The one with the power, right? What can I do with the power? bring it down. So I have x log 5 equals log 4. So what does x equal? Well, it'll just be log 4 over log 5. Which, what's that roughly now? 0.9 or something? 0.861. But as somebody said, you could use log base 4. In fact, you can use log base anything. But I'm going to stick to using natural log since that's on everybody's calculator. Okay.
When we mean natural log, it means that there is base 10.
Not base 10. What's natural log? Base E. Okay, 3a now. 4 power 7x minus 7 equals 7 power minus 3x minus 6. Once again, natural log on both sides. Natural log here. Natural log here. Okay, so what should I do now? Take the powers down again, yep. 7x minus 7 log 4 equals minus 3x minus 6 log 7. Now I know it looks a bit complicated, but we should just think of the log 4 here as being like a number. Log 4, log 7. So if you had brackets with a number, what would be the natural thing to do next? Multiply them in. So here we have 7 log 4x minus 7 log 4 equals minus 3 log 7x minus 6 log 7. Okay, I'll give you a minute to write that down so far. So all I did was open up the brackets. Yep. So let me just make a bit more space here. Okay. Now, forgetting about the logs and the rest, what would be the normal thing to do next here? Put the x's on the left and the non-x's on the right. So, on the left you have 7 log 4x plus 3 log 7x equals 7 log 4 minus 6 log 7. Now, we have two things with an x in it, so what would be the normal thing to do now? Put them together, yeah? So what's in common with the first and the second term? See, there's an x here in both, isn't there? And just to maybe make it a little clearer, I'm going to put brackets around it, because they're actually being multiplied here. So I can take the x out from both. So I have 7 log 4 plus 3 log 7 x equals 7 log 4 minus 6 log 7. And there's only really one line left to do. What should I do at the end here? What should I do? Divide by what? This square bracket here. Yeah? So I get x equals 7 log 4 minus 6 log 7 all over 7 log 4 plus 3 log 7. Now can somebody type that in please and give me the rough answer here? Yeah. Yep. Any base. I'm just picking this one because I know it's on everyone's calculator. What's that? Minus 0.127. This question is actually very common in the exam. I've seen it so many times, this one here. I think it's comes up maybe 3/4 of the time. In fact, question 3, 4, and 6 are the most common ones here. I'm going to do number 4 now. 4a. 9e2x minus 3ex minus 6 equals 0. Okay. Quadratic again. Slightly different though because you have this e in it. So here we get 9ex squared, yes, minus 3ex minus 6 equals 0. Do you see what I did there? All I did was replace e2x with ex squared. Yep. Now, mode 53 on your calculator, you get 2 answers here. One and minus 2 over 3. We could never get a nice number here like in the previous lesson. We could never get something like e squared or e cubed. So it means we'll never be able to compare the powers, which basically means the only way to go forward from here, which makes it different to the last lesson, is to do what? Is to put a natural log on both sides. Log, well here's actually special. Yeah. Log. Now, yeah, if you look here, you can see that what happens with natural log and e. Does anybody know or remember? Well,
It's 1.
yeah, look here, hey, look here. Log ex, what base is natural log? E, isn't it? So e to what power makes e power x? Come on, wake up. X. E to what power makes e power x? X. Anyways, my point is just this. Natural log and e always cancel. So on the left, that cancels that. I'm left with x equals log 1. And then here, that cancels that, and I'm left with x equals log minus 2 over 3. Now, does anything look wrong here?
Yes, minus.
Yeah, you can't take log of a negative number. So this answer is no good for us. Reject.
So we could just break it.
Yeah. This is the only answer that matters. Now, if you take out your calculator, natural log of 1, 0. So in fact, this only has one answer. The other answer you have to reject. Because the nice thing about natural log is it cancels the e. I'll say that again because we'll use that more than once. Natural log and e cancel each other. Maybe that's important enough even to write down. Yeah?
We'll get to it.
Focus. That's not.
No, it's not.
It's not. No. Actually, I thought this morning was actually warmer than normal.
Yeah.
Yes, but still too cold, huh? Okay. 5 now. Here, up there. There you go. In this question, I want you to rewrite all of these expressions in this form. So I want you to rewrite this as an a e power bx. So we'll have a look at doing that now. First thing I'll do, first rule of powers, separate this as 2 power 4 times 2 power minus 9x. So we're getting to the answer now. We need an a e power bx. What's the next problem we need to deal with? Well, you see this 2 here.
Yeah.
We would really want it to be
E.
e. This is how you can introduce the e. Remember I said log and e cancels? Yes? Well, actually the opposite is also true, of course. E and log cancels. So if I write here e and log like this, the e and the log, oh sorry, I'm missing my 2 now as well. Wait, don't write that part down. Right, like that. E and log cancels, so what am I left with on the on this part here? 2 power minus 9x. So this is the trick to get the e in. You just stick in an e and a log because they both cancel each other anyways. So you can just put them in, yeah, because e and log cancel. It's like, do you remember when we did the square? Yeah, no, not the complete the square roots, and to simplify the denominator, you multiply above and below by the what's it called? Conjugate. Yes. You multiply above and below by the conjugate, but if the top and the bottom is the same, what's that going to be? 1. And what happens when you multiply by 1? Well, nothing changes, right? So you've seen this kind of trick before. You put in something and you're allowed to put it in because it doesn't do anything to your numbers. So here if I put an e and a log in, they both cancel, they don't do anything. Yeah, it's more like e to the power of natural log of x is x. So I'll write it here. E log something just equals the something. The e and the log cancel. A lot like square root and square, cube root and cube.
So 2 to the power 4 is the a, and
Well, we're not quite there yet. We're getting closer. Here, what can I do with this power? Bring it down, 1 sec. All right, now what was your question?
What do you put the councils, right?
Yeah.
And we're left with 2 to the power minus.
Yeah.
So, yeah, what's the point? It's like,
The point is, I can introduce the E, because the question says, put E in the answer.
but doesn't the E cancel with them?
It does,
That is goes.
and I'm not going to do that. But you're right, it does go, but I choose not to cancel it here. You know, just like square and square root cancels if you choose to cancel them. Yeah. Now, can somebody please type in on the calculator -9 times log 2? Oh, and what's 2 for minus 16? -9 times natural log 2, what's that? Is it like 7? Minus,
6.24.
So then what happens to the x?
no, what I've done was I've multiplied the 9 and the log 2 but left the x there. Or if you want to think about it in your head, it's like I just pushed it to the back.
Why did you make the 2 minus?
Because my equal sign turned into a minus. So that, here, where's it gone? This here, you've actually written it like this. Why do you think it would be useful to do this? Why do you think it might be useful to do this?
Do
Man, why?
what?
To rewrite your power from this to the E.
Just to make the life.
Yeah, you're right. It's just to make your life difficult. Now, the reason is because sometimes you'll get equations with E in it or problems with E in it. And in fact, the most important reason is when we do calculus. Brendan,
Don't worry.
I'll come down there and slap you, okay? You're doing physics. Calculus should be like your top part of maths. Now, the reason is in calculus, we cannot find a derivative of this, but we can find the derivative of this, okay? So it's for later, for calculus. Okay, last one now, 6a. Okay. Before I solve this, I need to write down my possible values of x. Here, what am I allowed to do with x? What values can x be?
Only positive.
Positive. And here? Positive. So before I find the answer, I know that the answer should be positive. Alright. Now, what's the first problem here with trying to find the x? The x, where's the x here? In the base. And where is it here? In the argument. Also, I can clean this up a little bit. What can I do with 8? What type of number is 8? 2 cubed. Okay, so here will be minus 7 log 2x plus 3 log x2 plus 6 equals 0. Okay, how can I fix this problem with the base here? Yeah, switch it.
But doesn't that mean that you have to make it a fraction?
Which part? No, I'll just look at this. by itself in brackets?
Yeah.
Oh yeah, well it'll become a fraction, yeah. Now, it's not too bad now, but it's still not great. Here we have log 2x, and here we have log 2x, but the problem is one is in the numerator and the other is in the denominator. To make it a little bit easier to do, what I'll do is I'll replace, or I'll say let u equals log 2x. This will just make it a little easier to read. Minus 7u plus 3 over u plus 6 equals 0. Now when you write it like this, it doesn't look as bad because you've seen this type before. How do you go ahead by solving these?
Multiplied by u.
Multiplied by u. So this will be minus 7u squared plus 3 plus 6u equals 0. Or if you take everything to the right, 7u squared minus 6u minus 3 equals 0. Okay, what are the two answers here? Mode 53, please. Now, it will be possibly decimals, okay? Yeah. 1.21
Minus 0.25.
0.25. Now that's what u is, right? But let's not forget what u actually stands for. What does u stand for? Log 2x. So I have log 2x equals that, and log 2x equals that. Now if you think about it, remember what this means? 2 to the power of 1.21 equals x, doesn't it? And then likewise here, 2 to the power of
This one is
minus 0.35 equals x. Okay, so what are the two answers here? What's 2 to the power of 1.21? What's it like 2.4 or something? Two. And then this one here? Zero point 78. 2.3. Yeah. Now, can we use both of these answers? Yes, because at the very beginning I said we're only allowed x to be positive, and both these answers are positive, which means you accept both of them. Both are fine. My advice also is you should put these answers back in to check that they work, but not necessary right now. Yeah. Yes, yes, yes. Why? Because I don't want the x to be in the base. Where the x is in the base here. Don't like that. Now the x is not in the base. You can swap them. I think it's the fourth rule of logs. Scroll down. Teddy. Okay, so the ones I'd like you to try now, the last three of each. That's not as much as it sounds because number one is virtually no work, okay? So the last three of each, please. You can start it now.